town hall. Yes, we are recording. Thanks, Erica. Yeah, so just the usual introductory stuff. Please mute unless you have a question. I think we're happy to entertain questions. You can either put them in the chat or jump in, and I think we're good pretty much anytime. Yeah, so our approach today is that John Longbottom, our CEO, is going to give a quick one-slide review of what's happening with the whole transition to the Alliance. Then it's great that the UBC team has been looking at commercial cloud and have done been working for quite a while now. Got some really nice stuff going on. So Matt Smith has been and the team are going to give us an overview. I've got a small operations update, and then our usual update on the training events that are happening. So John, I think over to you. There's your slide.
Yeah, thanks, Patrick. And hello to everybody. And I'd just like to reinforce that we're really happy to have the UBC team on today. In some conversations we've been having recently with the Alliance, et cetera, vis-a-vis cloud, members of our own, regional institutions are doing some really great work. So it's wonderful that we get a chance to have them here today to talk about the exciting work that they've done. So I just want to personally thank them for their participation today, and my hope is that there will be more to come as we move some of that knowledge and expertise and experience into the larger Alliance program and strategy. So I want to just provide a few highlights of where we're at, more broadly speaking, with the transition of the Alliance. I think there's been some phraseology used transitioning to the Alliance, and that's actually not the case. So let me just go through at a high level a few points. First and foremost, all of this work is really centered around the focus around our research community, the researcher, the support staff, and of course, the research. And that really is the prime driver of all of the effort that we're focused on, not only in the transition, but as well, for the sustainable period moving forward. Number two is the fact that it's not really about transitioning to the Alliance. The Alliance is actually transitioning into the existing federation, into the structure that exists today that actually supports the programs and the services, the capabilities that we've been relying on for years and years. And that's really an important designation. In the next fiscal, and by the way, the next fiscal year, 2022, 2023 is going to be a transition year. For a set of reasons. I'm not going to go into all of the reasons, but it is designated a transition year. And in that transition year, that the emphasis is really around building a new service delivery model to be able to figure out the national, regional, local services, where they fit, how they fit, rationalize those. That'll be a really key component of the work effort during that year. And of course, mostly important is the sustainable funding model, and how we actually create a model that has a high degree of sustainability based on bringing in more consideration in terms of what could be used for matching funds, eligibility, et cetera, based on a framework of verifiability that will be developed during that period of time. The Alliance has got their strategy approved now. It will become public by the end of December, and that really is embodied in their mission, their vision, their priorities. And they're working on, and when I say they, we collectively are all working on an Alliance DRI implementation plan, which will be ready by the end of April of next year. And that will consolidate and integrate the strategic priorities of the Alliance itself, existing requirements that we have, and of course, to build a much more seamless integration of ARC research data management and research software. Of course, Compute Canada is tracking to transition staff and processes over to the Alliance, and that is tracking very, very well to completion because at the end of March, Compute Canada goes away, as some other entities might as well. And then lastly, just on the point of, sorry, Patrick, let me just, so just on the point of the funding model, the next fiscal year will be based on existing criteria that we've become familiar with in the world of CFI MSI program. And they're going to try to keep most of what we do business as usual for the next 12 months. And but most importantly, we will be building ourselves into a pretty significant funding envelope that's up to $50 million a year in operational funding, as well as $60 million a year in capital. That's the federal contributions without the match. So when you put in the match, which by the way is always the challenge, is getting the match, but assuming that, we have some pretty significant opportunity for growth. So those are the highlights of what's going on in the Alliance. Certainly, anybody has questions at some point, by all means, we're more than pleased to talk it through or to find you somebody who can answer those questions. But I just wanted to give you a quick high-level view of where we're at on the Alliance. So Patrick, I'll turn the program back over to you.
Yeah, thanks, John. That's great. Yeah, and thanks for that quick overview. Lots of exciting things going on right now. Yeah, at that point, I think, yeah, welcome to Matt. He's the Manager of Research Systems at UBC, and I think, Matt, you're going to take over the sharing. So I'll stop sharing my end of things. And yeah, over to you.
Awesome. Thank you, Patrick. Can everybody see my screen just fine?
Yep, coming through fine.
So yeah, thanks for the introduction. As Patrick said, I'm Matt Smith. I'm the manager of the research systems team here at the University of British Columbia's Advanced Research Computing Unit. And I'm here with the rest of the cloud team to talk to you a little bit about what we call our adventures in commercial cloud. And yeah, we'll get a chance to introduce the rest of the team and their involvement here later in the slides. So I can find out how to change my slide. So here's what we'll be covering today. We'll go over an introduction. We'll talk about who we are, what we do as a unit, just to provide some context, go into the team. We'll talk a little bit about our on-premise systems as it's relevant as we dive into our cloud explorations and summaries. We'll speak a little bit about, well, we'll dive right in to our cloud work, speak about some of the future direction, and have some closing notes. So first, who we are. We're Advanced Research Computing. We were founded in 2017 through the efforts of our director, Steve Cundy, and the Vice President Research and Innovation, Gail Murphy. We're positioned under our Vice President Research and Innovation portfolio to focus on accelerating research, in contrast to VP Academic, where units such as UBC IT or UBC Teaching and Learning Technologies are nested under. And when we were founded, we initially supported almost solely the national and regional DRI resources, digital research infrastructure, which most of you are familiar with that acronym. We also supported and launched institutional platforms on central UBC IT infrastructure and effectively established ourselves here as an instrument of science. Now, in about 2018, UBC identified that there were additional needs. We heard from researchers that were encountering issues with queue times, limited resources available, requirements for things like graphical user interfaces, and pieces that were, I guess, difficult for us to coordinate with the existing resources. So the Board of Governors approved a capital investment in 2018 and topped that up in 2019. And as a result, we were able to nearly double UBC researchers' access to compute resources. Now, who made this all happen? These folks right here. And you'll hear specifically from Ben Hademan, our cloud architect, who designed and really engineered a lot of the cloud solutions that we're going to cover. Jacob Boucher, who had a heavy hand, particularly in our cloud bursting pilots. And Ken Bigelow, who is our end user and training support extraordinaire for the cloud. Now, let's talk a little bit about our on-prem infrastructure. So we have SOCKEYE. We have 16,000 cores that are available here to UBC researchers as part of this institutional offering. We have a bundle of GPUs that are available. It's all powered by Mellanox InfiniBand. And we have a collection of storage that's attached to our computational capabilities. We also have CHINOOK, which is our object storage platform. And it's about, right now, I list 20 petabytes of usable storage. Right now, we're offering roughly 10 petabytes to the research community. And we're able to process applications for up to 160 terabytes automatically, with larger asks going to a researcher-led panel that essentially adjudicate who gets what. And this is geo-replicated. So as many of you are aware, UBC ARC spans across both campuses in Vancouver and the Okanagan. And we have our counterparts in the Okanagan that manage the backup site. And all of this is powered by the Science DMZ concept and architecture. So yeah, we have 200 gig primary and secondary links. The compute nodes do not have access to the internet by policy. And we do not have a firewall in order to preserve network throughput, at least not in the middle of our scheme here. Now, we'll dive right into the public cloud. So much like how ARC took on institutional offerings to address gaps that researchers perceived were present, we were also hearing from researchers that even the institutional offerings weren't meeting certain needs. Just like any finite resources, they're exactly that, they're finite. So we're hearing from researchers that wanted that ability to, let's say, burst to 7,000 cores in order to meet a research deadline that they didn't know was important to them until 1 week before their publication was due. Or we were hearing from folks that were non-traditional users of computing resources, such as the Faculty of Arts, that they wanted easier to use platforms, and they were being told that the cloud was able to offer that. As such, we were commissioned with a small budget to explore how we can facilitate research computing on the commercial cloud. We started with Azure as the first pilot, where we provided technical support for projects on what we call vanilla Azure, using the platform itself. And this included compute, web, and Internet of Things projects, notably a smart city project run by the Urban Data Lab here on campus. Then we decided to launch 2 platform-oriented proofs of concept, because we were noticing that vanilla cloud wasn't really usable by researchers. They were having to learn a whole proprietary set of technologies in order to just get their projects off the ground. And so we selected these 2 proof of concepts to bring users what we call up the stack, or essentially abstract away those cloud layers and give them either an interface that's familiar to them, that looks and feels like traditional HPC, or look at web-based interfaces for accessing the public cloud. As such, we selected RONIN. You can look up RONIN at ronin.cloud, and Bright, which is a cluster manager. They have a cloud director as our platforms. And with that, I'm going to hand it over to Venkat Mahadevan, our cloud architect, to speak to RONIN.
Thanks a lot for the great intro, Matt, and hopefully I'm coming through okay on the audio. Let me know if it's a bit soft. I'll speak louder. So yeah, just as Matt said, one of the ideas behind this was based on our experience with existing cloud platforms, including our existing Compute Canada cloud, which is built on OpenStack, and experience of the first pilot, which was Microsoft Azure. One thing that we did notice is, yes, these are extremely powerful platforms. They're useful. They provide a lot of feature sets that researchers want. But the problem is the entry curve is, or the barrier to entry is quite difficult for a lot of researchers, primarily because you have to essentially become a systems administrator to actually do the work on these platforms, right? They don't make it easy right off the bat to use. So the initial idea was, okay, how do we offer something that's a bit more abstract, provides the core set of functionality that most researchers are looking for? And just based on my kind of anecdotal, but I think it's a fairly good guess that it's kind of the 90-10 model. Can we serve 90% of the use cases with the platform, and maybe the other 10% we need some customizations? That's kind of how it works usually. So we selected this platform, RONIN, that runs on top of AWS, and it provides an interface for some of the most commonly used services. If you look on this diagram, you can see some of the services are autoscale clusters, which is essentially a high performance computing in the cloud. Traditional HPC with Slurm scheduler, like what you're used to with the Compute Canada systems. You also have virtual machines in the cloud, whether it's Windows or Linux, with the virtual desktop, so people can just log in, use a desktop environment like they're sitting there locally on the machine. Object storage, which is a centerpiece of a lot of things that are done in AWS for your storing your results, storing your data sets, and so forth. And packaging of software. So you can package things like Jupyter Hub, you can package things like RStudio, various packages that sometimes are difficult to install for a user, but with this, it could be a one-click installation. And all of this is segmented into different subnets per user project. So the security is fairly good. There's no communication or bleed over between the different projects. So each user gets an isolated environment. They can do what they want. And on top of all of this, you get the budget management piece as well, because as you know, when you run in commercial cloud, it's not free essentially. You do have to pay for the resources that you use. So actually being able to track your expenses in an easy to use fashion, RONIN provides that as well. So it's a kind of a nice feature set. Next slide, Matt. So you can see here, there's a little bit of a screenshot that just shows you some of the user interface features. There's project machines. So you can have a list of machines that you're running, different machine types, GPU machines, CPU machines, different amounts of local storage attached to each machine. And these are all self-service. So essentially, there's no intervention from us as the system admins. The user has full control to set up whatever resources they want. You can set up predefined packages. They want MATLAB, for example, single-click install of MATLAB, single-click install of Jupyter Hub, et cetera, et cetera. Same with HPC. You could set it up with a predefined set of software to run a certain number of nodes, up to 120 nodes, and different types of application servers. So the key thing is the way we wanted to differentiate this pilot from our Azure pilot, or even what's being done right now with the Compute Canada Cloud, is abstracting away some of the most commonly defined tasks, what the user wants to do, because essentially the research is what you want to focus on. You don't want to focus on administering systems and spending a lot of time on that process. And I feel this is the path, whether it's on-prem systems or commercial cloud, the idea of providing platforms versus just infrastructure as a service, this is where things are headed, primarily based on our years of experience with operating the infrastructure as a service cloud, where yes, it works well for labs that have a lot of dedicated resources, whether it's a postdocs or sysadmins that can help out. But it doesn't work so well for labs that are smaller, might have less funding to hire such resources. So this is where we're trying to like steer the direction, make it as easy to use as possible for self-service. Another nice feature about this platform was very easily integratable to our identity management system at UBC. So you have a UBC account, you have a role at UBC, you can get access to this using your single sign-on credentials. Next slide, Matt.
Venkat, I see there was one question. Barbara asked if Cognito does backups of VMs and such in an easy to use fashion.
Cognito is not a backup tool. Cognito is an identity management tool that RONIN uses. So it's an AWS service that's used by RONIN to actually do the integration with SAML 2.0
Right.
or Shibboleth provider. So it doesn't do backup. I mean, backup is always, RONIN does have backup in terms of you can take snapshots of your disks and so forth. So that's one aspect of doing backup. But a true backup, you typically need a third-party software like Veeam or something that backs up your VMs and so forth, right? Because you want to do an offsite backup. Maybe with AWS, it's not as important because it's highly redundant with different regions and so forth. But no, Cognito is just for identity management mostly.
Right. Yeah, thanks. And I had one question too. You talked about HPC using RONIN, which sounded really interesting. Are you using the the Compute Canada software stack then, and it's kind of like Magic Castle?
So
Can you
we're
run
not
Magic
using,
Castle for that matter? Yeah.
yeah, so we're not using the CVMFS, although it's integratable if we wanted to do that. So we could put the software stack in a machine package of Ronin. So that's kind of one of our to-do list items. So what it does use in the back end is AWS Parallel Cluster, which is the AWS solution for providing HPC. But Magic Castle could be used as well, because pretty much all you would have to do is just package up a machine and have it run. The nice thing about the AWS solution, only because it's integrated into this, is the auto scale clustering capability, where you can set up either spot instances or on-demand instances as well, and you can set the price for spot instances as well.
Cool.
There's a little bit of additional features. The main thing with commercial cloud, the difference, and I'll talk about it a little bit in the budget management piece, is that unlike the on-prem solutions, you have to be very conscious of the budget that you're using up. I mean, a lot of times, yes, it's just credits that you get as a grant from AWS or Microsoft, but ultimately you can't leave your things running all the time. I kind of try to look at it as a light switch analogy, that you use the service when you need to and then turn it off when you don't need to, right? It's very utility type computing. So even though, yes, you can integrate things like CVMFS and some of the other services in this, you definitely want to be cognizant that you want to keep things running all the time when you don't need to, right? That's kind of, and you want to have auto scaling as well as a capability. And that actually leads into the question of budget management, like how do you manage the budget? Well, Ronin, one nice thing about it as well is it gives you the up-to-date stats on how many dollars you've consumed out of the budget that's allocated. And you can set a time limit, you can set a time limit on projects, like when you want them to expire, but also a budget limit on the projects. And the budget limit, once it's hit, it can either trigger an email notification saying, hey, you've hit the budget, we're going to pause your project now, which will pause the project, but it'll keep the storage available, because typically storage is a lot cheaper than compute. So storage doesn't hurt the cost as much, but compute is quite expensive in the commercial cloud. So definitely managing the budget is a key piece of this. And this is one of the harder things with the vanilla solution as well, sometimes having budget overruns. And a lot of commercial cloud projects become super expensive because you have lots of VMs running that aren't really doing useful work. So this really helps avoid that. All right. Well, I guess I'll pass it on to Jacob to talk about our cloud bursting on SOCKEYE pilot.
Sure. So one of the other pilots that we were looking at is how we can integrate cloud solutions into our already existing on-premises hardware. And through our cluster manager that's provided by Bright Computing, they now have a cloud bursting toolkit that is part of their whole solution. And essentially, this allows us to create a section on AWS to CloudBurst 2 that exists as an extension of our on-premises hardware. And Bright does this by basically setting up its environment in a tenant that we provide it, and builds its environment within there and connects to our local cluster. Now, this will let us, either as UBC Arc, or if one of our users want to provide a cloud tenant for us to set this up in, attach that tenant to our system, and then we can control what sort of images are being put onto the VMs and having them connect up to our cluster. Now, the wrapper that lets us do all this within Bright Computing essentially links in with our queuing system. And on SOCKEYE, we use PBS instead of Slurm, but it also would apply to the Slurm scheduler as well. And this wrapper script basically lets users submit a job that looks very similar to what you would submit to the standard queue, with just a few additional options. And the one other really nice feature is similar to how Ronin can do auto scaling. Bright also includes a auto scaling feature that will monitor the queue that's attached to the tenant. And as the queue fills up or drains, will start powering on and off nodes to basically keep the system at the most efficient running of those compute nodes that you have attached to the system. So this is a very rough diagram of what the cloud bursting solution looks like. So on the left here, we have at the bottom, that's our on-premises hardware. So you connect into the head node or login node, and that's connected to, you know, the standard compute nodes within the cluster. When you add in the cloud bursting, it opens up, basically sets up a OpenVPN or AWS Direct Connect tunnel to the cloud and creates its own environment within the cloud that consists usually of a cloud directory that does all of the management, and then any number of the compute nodes or storage systems that are attached and set up to run jobs that are pushed to the cloud. So when you submit a job to try to replicate the environment that is on the on-premises system, you need to specify what your input files are. So say you have software you need, or you have some like a collection of data set that you need to run your software against. In the job script that you do the submission in, you basically need to tag those input files. And what will happen is the wrapper script will take those input files and then push them up to an S3 bucket that then gets attached into the computing hardware that's used in the basically cluster extension that's in the cloud. And once the job completes, there's another flag that you can set up in the job script to tell it, okay, the job is done. These are the output files I need. And when the job finishes, it will then take those output files and then copy them back to the head node and put them back on the cluster. So effectively, it replicates the ability to write directly to, say, like your Scratch directory in the on-premises hardware just by doing copies to and from the cloud. And on the right-hand side here, this is kind of a general overview of like what is being provided. Now, we don't use a private cloud or Bright OpenStack. So primarily it is, we have our Bright Cluster Manager that sits on our on-premises hardware, and then it can push anything up to the public cloud to basically use that as an extension of the on-premises hardware. Next slide. So for the actual proof of concept that we're working on, we're in the early phases of testing it with a few of our users right now. The main way that we're setting up the environment there is by using Singularity containers. And this was done primarily to ensure that when we have something that runs on our local system, we can also have it run on any of the AWS systems without having to worry too much about having the exact same configuration, since everything would be, for execution, would be isolated in the Singularity container. Additionally, this makes it much easier for that step where I was mentioning needing to upload any of the input files. So if you have a single container, that's only one file you need to upload along with whatever your data set is. So we have Singularity set up in the images that are on the cluster extension as well as on SOCKEYE, so that you can run that container on either the on-premises hardware or on the cloud. And one of the nice things that we're looking at potentially for the future is, since Bright has the ability to split off multiple cloud bursting deployments and set them up each in their own queue, when I was talking previously about tenants, we could have researchers come forward with, we have this tenant in AWS or Azure, we would like to set up this as our basically our cloud bursting fund. We can attach that, we want to use SOCKEYE, but we'd like to have that as cloud bursting. So we can set up that environment in their tenant by them providing us the credentials for it. And Bright will spin up the environment, and we just can attach that queue in SOCKEYE to their account and let them burst up to that tenant using their own credits, rather than having to do a transfer or something to Arc and provide a tenant themselves.
Jacob, just how about the actual data transfer? You know, a lot of the stuff happening now is pretty big data sets. Does the the cloud burst still have access to data that's on the central system, on the on-premises?
When you do the cloud burst, you need to push up any of the data because
Right.
unless you have AWS Direct Connect, you can't directly mount systems that are in the local system. However, what you can do, and what I've been working with some of our users on, is when you do the cloud burst, you can specify specific files with tags. And if those files are already present in the S3 infrastructure that's part of the cloud bursting, instead of doing another upload or for it, it will just say, oh, I already have this. This is tagged with this file. I'll just use that. So then rather than having to upload every time for a job, a large data set, you upload that large data set once, and then it just extracts it from the bucket.
Cool. Yeah. Okay. I hate to ask, but do you end up with a special costing for both input and output? I mean, transferring up to the cloud is usually pretty cheap, but transferring back from the cloud is, notoriously expensive.
Yeah. So in general, because of the low or free cost of ingesting data, we're not too worried about them pushing it up, other than our use of the S3 buckets and the data size. Pulling back down, in general, those are going to be your output files, and ideally you would like to, whatever your output data set is, to be compressed as much as possible, either by just reducing the files in your job script that you need to copy back, or doing compression on disk in the cloud. Now, for our initial test set, the egress from the system is fairly light. If we were to go forward with this, and there's going to be somebody that has very large egress, so say they're setting up a large data set, they're doing manipulation, say like image manipulation or something, and then they need to pull all of those images back, then we'd have to discuss with them and say, is this something you actually want to cloud burst? Because the egress fees will be a significant impact on pulling that data back and forth. And that might be something we'll need to discuss with when somebody comes forward and says, I'd like to do cloud bursting. Here's kind of what my workload is going to look like. That might raise a flag for us saying, okay, you could do cloud bursting for this, but the charges are going to be fairly high. Is there a way that you can split off doing that sort of work on our local system, and then have something that is lighter weight for data transfer be pushed to the cloud burst, so you can kind of divide up your workload that way?
Yeah, thanks.
Is there any other questions for this section, or should I hand it off to Ken?
And Jim's asking, what's the pricing on Ronin?
Well, I will hand it over to Ken for now, and then we can answer any of the other questions for this at the end. So.
All right, next slide, please, Matt. So with all this above information that everybody's giving us, there is also the training side of things. And that's sort of my favorite part of the of this whole process. And I like to, we all like to let the researcher really give us a good description of what they want to do, what they're trying to accomplish. A life story, one would say, for the project that they're working on. And this is just because maybe the public cloud isn't the best solution, just because of, for example, egress fees that Jacob was mentioning. But if they are a good fit, that's where I get to have a lot of fun and get the understanding of the cloud for them, so that they're on a path to success. That generally is very similar to how on-prem HPC training works, as well as OpenStack training works. There's very few differences. You can have your dashboard, obviously, that's a little bit more intuitive, but CLI access, object storage, egress best practices, security, SSL keys, all of that in the back end is really very unique and very, very different depending on what platform you're using. Basically, if we get this done right, we're going to save a lot of time for the researcher down the road. They're not going to make any costly mistakes, because the public cloud, you can make costly mistakes. If, for example, on a Friday night, you shut down your PC and you forgot to shut down the P4D 24X large with 8 A100 GPUs, and then you came back Monday and your budget was blown because you left that on and you lost $20,000. So that's a mistake we don't want happening. So we do regular follow-ups to make sure that everybody's happy. Sometimes we'll get them onboarded and they'll not come back to us, and we'll notice that their resources aren't being used. So it's always nice to take a peek and ask if they need any help. And it could be something as simple as a quick software install. If everything goes well, your researcher will have all the keys, will have all the access, and life will be good, and they'll be able to roll along really nicely. Next slide, please. And this is the future direction for where we're sort of playing right now. For explorations and pilots, Exotanium, that's all about trying to figure out how to keep jobs running in a spot market and shift the jobs between compute nodes without losing the skip or heartbeat. You got the automation side of things for infrastructure as a code. Managing, basically being able to manage your full stack compute operations from a desktop, from a command line, or not from a command line, but from a web app on a laptop even. And all the way to enhancing user experience with the public cloud. And with that, does anybody have any questions?
Yeah, thanks. That was a lot of stuff there, and you've done a lot of work. That's really nice to see. Yeah, any questions for anybody out there?
I can address the pricing one right off the bat. So RONIN offers a special pricing model to educational institutions. Their base model is based on users. So they essentially have I think it's a 50 user license, 100 user license, and then a site license. And the difference between a 50 user or 100 user license and a site license is not that substantial. So they really are encouraging that, kind of wider adoption. And I think, I'm hesitant to list any prices right off the bat, because the last time we were quoted on it was a couple of years ago. We purchased a 3-year license period, knowing the length of our proof of concept. But if anybody is interested in pricing, it's not egregious. It's definitely reasonable.
Yeah, thanks for that. And how it's a proof of concept, but I guess you got a few users who are actually working with it. Can you give me any idea of sort of what those users are doing and how they're finding the service?
Yeah, the number, I can give you the number right now on RONIN. We have, I think, around 130 users. And then
Cool.
I'm not sure, Venkat and Ken, do you want to dive into some of the cool usage we're seeing?
Yeah, so I mean, there's a lot of use of the auto scale clusters, because essentially it provides you with standard Slurm scheduler. So people that have used the national systems but just want some additional capacity can run with that. We have people running MATLAB, people running Jupyter notebooks, we have people running R, Python scripts, PyTorch, things like that, TensorFlow. So pretty much a lot of the software that's running on the traditional HPC is running on this as well. But a lot of people are also doing a lot of interactive work, and that's where it shines quite a bit, because you get a pretty high performance remote desktop environment as well, without any sort of limitations on the number of hours that you can run it on, like with an interactive node, for example, right? So I think definitely some of the niche use cases, Windows is a big use case as well. If people want to run some very particular software that runs only on Windows, or that's what they're comfortable with, but you want a lot of cores running on Windows, that's a service that's not provided on any of the national platforms. We have very, very limited capacity for that nationally. So that's definitely one of the big use cases there. But yeah, pretty much it runs the gamut from your traditional HPC applications, but there's quite a bit of interactive work there. Stata is another software package, and maybe I'll let Ken have a word of that, because he's been supporting quite a few users on that as well.
Yeah, so for the software installs side of things, yeah, we basically, what happens is that when they when they have a software request, then we get more than one. What we'll do is we'll package it up into an image and a pre-built package, so that when the user, when the next user requests it, we just say, yep, you just click that button and you build it, and it's a one button build. Yeah, and yeah, we actually had a really cool user. We had a guy, a researcher 2 weeks ago, spin up 120 C518X large nodes. Basically, that capacity was half of our on-prem SOCKEYE. They did that in the cloud. It was amazing, actually, to see that.
Cool. So they were getting some big computing done. That's really nice. Yeah. Yep. Well, a job like that, though, that would be, that's a distributed job, distributed memory with MPI or something, or?
I'm not sure the details of the job. I was just looking at the dashboard. We were looking at the dashboard and we noticed that.
Yeah, and I think that's gets to another good point in that some of the jobs, yes, we can look and see how many VMs are powered up, things like that. But one of the nice things of commercial cloud, and I think this is not Ronin specific, is that we really don't have to monitor what people are doing in it. Like if they do something that's really bad, it doesn't affect anybody else, right? They're running nodes, it affects their budget. They're doing something bad, it's not useful. But if they're running something and it's really hammering the file system or doing some strange things, we really don't care about it at the end of the day, because it doesn't affect any other users. It's isolated. And that's one of the nice things I would say about commercial cloud is like, yes, maybe somebody does something really bad, it might affect Amazon in some way, although I haven't heard of that. But there's a lot of isolation. So yeah, we can see how many VMs are running, how many nodes are running, and so forth, right? But we can't really look inside because it's truly a self-service platform. I think whether it's Ronin, you know, I saw the comment from James, and I think, yeah, James, this is just a POC. I don't think any solutions have been selected or any discussions have actually been happened with that. This is purely just a technical POC that we've done at UBC only at this point, right? So I don't think there's any worries there. I'm pretty sure powers higher than myself will figure out what they want to do nationally. But my point about the commercial cloud, yeah, one of the nice things, there are downsides to it as well. Pricing obviously is one of the big ones, but it's truly very low touch. I mean, in terms of system administration, the amount of actual system administration we have to do to care and feeding of what the users have to do once we give them access, with those 130 users that we've had, the amount of actual support has been extremely low. They click some buttons and they go running. So yes, you pay a license fee, but you reduce your support costs. That's been one of the positives.
Yeah, thanks, Venkat. I see there are a couple of just notes really, but Marjorie, yeah, Canadian consortium pricing. Yeah, I had a note to myself about that one too, and thought that I would try to pass that back to the Alliance. And so, yeah, I think this is definitely worthwhile looking at from the national platform end of things. Some comments from Jim about about Amazon only, but maybe that will be extended out to other platforms too. So, well, sounds good.
Yeah, the one thing I'll note about Ronin too is that, you know, like any of these vendors, that relationship is important. And you know, every private company, they're in it to survive and make a living for themselves. But at the same time, Ronin came about for researchers. The founder built Ronin to support PhD work that his family members were engaged in. He was a programmer, and he saw a challenge in that these researchers being thrown at AWS by their universities and being told just to learn it and make the research happen, and they weren't really able to do that. So this solution was built with that in mind. And my understanding, don't quote me on it, is that AWS was chosen because of the flexibility. They ran into inflexibilities with the other commercial cloud providers at the time of creation. And so that was really, you know, it wasn't any sort of backroom deals. It was more out of necessity.
Cool. Well, thanks, guys. I think that was an excellent presentation. Couple of more comments there, but I'll keep track of those. So yeah, thanks a lot. And if you can stop sharing, then we'll continue on, and I'll do a quick update on my end of things. Cool. And of course, you can pass any other questions that anybody has back to me, and I can pass them on to UBC or direct on to the UBC team. Yeah. Let's see, am I sharing the right screen there? Everybody good? Yep. Okay, I've just got a few quick notes here, and I think it's just so interesting to hear about the cloud end of things. But everybody's usually pretty interested in RAC, the resource allocation competition. So that closed back at the beginning of November. We ended up at the moment, I think we got 716 applications. That's up from what, about 650 last year. So we're still seeing this linear increase in the number of applications. That number may change a bit depending on all the reviews and such, but that's the rough, the preliminary number. So man, yeah, we're just continuing to see a lot of demand for these kind of computing resources. Of that, WestGrid got 220, which is about 31%, and that's pretty normal. We always end up with 30 or 31% of the applications. There's a quick breakdown there. Yeah, we hope that everybody will take, or that as many people as possible take fast track, and that's just the year by year, almost automatic continuation. So it just takes a relatively straightforward review, and about half the requests are fast track. So that's great, but we still end up with a significant number that we need to do a full review on. The technical review is happening. That's us, the technical, the staff work through all of these and just have a quick look to see if the requests and such look good, and there's nothing glaring. The science review has been sent out to the reviewers. I've forgotten, there's something like 10 or 12 separate committees this year. We just keep having to increase the number of committees, and it's off and running. We meet in February, early February, to review all the scores and do the actual allocations. We meet with the chairs of the review committees, and as usual, the announcement should go out in mid-March and start up in early April. The Alliance, which will be taking over in April, has accepted that we're going to do, as in Compute Canada Federation, we'll do the whole RAC process this year, and they'll take over for next year. I put a couple of notes there that the CPU ask is about 80% more than we've actually got, almost twice as much as we've actually got. So demand is also, I mean, just ramping right up. And the GPU ask is 5 times more than we've actually got at the moment. Now that'll be cut down as we look for these special ones and the ones that have made some mistakes. But it's still, it's going to be a tough year again, and this includes the new machine. The good news, I think, as John mentioned in that first slide in the beginning of the talk, was that the Alliance has significant capital funding. I think John mentioned 60 million available if we can get 40 million of match in the 60-40 split. So that's great. We're really hoping, and the Alliance and the Federation, the sites and such, have started on a planning exercise. So I hope we'll have some really nice announcements to make, but probably next summer. The other one I thought I'd talk about very briefly, and I'll do this very briefly, just that Narval, the new machine up at in Quebec, is up and running as of early November. So it's a big machine, 80,000 cores, the AMD chips, and I see it's number 83 now in the top 500, and 23 on the Green 500. So it's a very efficient machine. So it's on the default. Everybody's got access to it. It's got the HDR InfiniBand interconnects. The one point here on this slide is that the way they've got it set up with islands of nodes, we come out with a max of about 3,500 cores in an island. So that'll be direct connect through the one hub. So it's actually pretty good for up to something like a 3,500 core job. After that, of course, one should go to to Niagara, the big parallel machine at Toronto. Storage is exactly the same as our standard Compute Canada store shared file system, so home, scratch, and project. Yeah, available November 1st. I have one note there. Beluga, the old machine there, is actually going to need to be moved to the new data center. That'll happen probably starting in January. So all the compute allocations are now already available on Narval, and in fact, still on Beluga. So there's kind of doubling up there. But all Beluga users, if anybody's out there, should be moving to Narval right now and make sure your jobs are going and everything's working well. And then in April, when RAC comes in, we'll have both Beluga and Narval available and allocated. So that's really nice to see. That's a big machine, and it looks like it was on budget and on time, which is really nice. Alex, I think at that point, unless there are any questions there, I don't think I need to say too much more. Yeah, Alex, I can do the slides here. Yeah.
Yep. Thank you, Patrick. Yeah, I'm here. So yeah, just a quick set of quick slides on training and outreach. So I'll start with the webinars. We're now close to the end of the fall webinar season. We have only one webinar remaining. December 8th is going to be on installing software with EasyBuild on clusters. And the links to the webinar, you can find the links to the webinars these seasons and the next year's seasons on this slide. And also, if you go to westgrid.ca, click on training, it will take you to our training portal, and there you will see all the schedules. So next season, sorry, previous slide, please.
Yep, sorry.
Yeah, next season, we're putting winter spring 2022. We are still putting together the schedule, and if you check this page at the bottom here, the short link, sometime in early January, you will find the full schedule. So for our webinars, as usual, if you click on any upcoming webinar, it will take you to the registration page where you can register and receive the Zoom link. If you're interested in recordings, click on any previous webinar, and then it will take you to a page with the slides in YouTube recordings. And we actually maintain an archive of these recordings going back five and a half years, I think now. Next slide, please. Thank you. So on our other training, we are doing, together with other consortia in Compute Canada, we're doing a series of national training workshops this year. So we already had a couple of workshops, and WestGrid is leading a couple of workshops next semester. So the first one is parallel programming in July. In February is a 3-day workshop, and the second one is a similar parallel programming 3-day workshop, but now in Chapel in March. And if you're interested in these or in other workshops in this national series, please keep an eye on our communication, on our email. Usually we include all that information. We also, for the past couple of years, we've been collaborating with UBC Research Commons, Library Research Commons, on a monthly WestGrid workshop series. And now, since all training is happening online, all these workshops are open to non-UBC researchers as well. So if you're interested, check sometime in early January, check the webinar schedule. And at the bottom of this page, we also have links to registration pages to other workshops, including the UBC Research Commons workshops. Next, the big one is the WestGrid training modules. So this year, in summer 2021, we had the summer school, which we rebranded as training modules. And the reason is because now it's not a single event, it's more of a series of events covering 3 or 4 months. So we're hoping to do the same this year, starting probably in April and running into July. So we expect to have about 15 full-day courses on various topics in advanced research computing, starting from basics, introduction to HPC, programming, parallel programming, cloud, scientific visualization, and various topics in machine learning. So the idea is that these will be open to participants from all Canadian institutions, and we hope to announce this in March. Now, we also do invited workshops for WestGrid member institutions. So if your research group is interested in a custom workshop, please send us an email, so training@westgrid.ca, and we'll be happy to deliver or develop a custom workshop for you. And also, I want to stress that we are interested in collaborations to incorporate WestGrid training into research courses, into graduate level courses, because I know a lot of grad students, they do not really know the details of advanced research computing topics, parallel programming, etc. And we're more than happy to bring this to your graduate level courses. Next one, please. And my final slide is scientific visualization. So as many of you know, for the past year, we've been partnering with IEEE to co-host the 2021 CIVIS contest. So the contest wrapped up in, well, the deadline was end of July. We had 7 really good submissions, and everything was presented. The results were announced at IEEE VIS conference in late October, a few weeks ago. And then in early November, I delivered a workshop on a webinar on the results, so the ideas and highlights from this contest. And this webinar is available on our training materials website. I also have a quick link here as well. And then going forward in 2022, we will also participate in the next year's IEEE contest. So the data set is already online. The contest has started. And it's going to be, so the model is a 3D forest fire propagation simulation. And if you're interested, go to the website. And also the website, if you go to this year's website, there's a link to the 2022 contest there as well. So I hope you'll check it out. That's it for me. If you have any questions, please you can ask them now, unmute yourself, or send an email to training@westgrid.ca. And I just want to mention also that we're always looking for topic suggestions. So if you find that there's a topic that you want to see in our training, but is currently not covered, please let us know.
Thanks, Alex. Yeah, it was great. And yeah, that IEEE VIS, man, there were some brilliant visualizations going on there. If you didn't attend Alex's webinar, well worthwhile having a look there. Those are some of the best folks in the world working on that. Yeah, so thanks. Any questions for Alex? Yeah, well, I think we pretty much reached the end then. Thanks everybody for attending. Yeah, of course, support at WestGrid or support at Compute Canada, or you can certainly get in contact with us directly if you'd like. So thanks everybody, and thanks to the UBC team again for presenting a great thing, great overview of their efforts with the cloud.
Thanks so much for having us again. Really appreciate it.
See you everybody then. We're done.